Hi everyone, welcome to G World of Academic Physics. Today we will discuss one of the application of the electric field, that electric field at the center of a non-conducting hollow hemisphere having surface charge density sigma. This sigma is called surface charge density. Let me one more time repeat what we will derive. Today we will derive the expression of electric field at the center of a non-conducting hollow hemisphere having surface charge density sigma. When you are talking about a hollow hemisphere, this hollow hemisphere is an extended body. Solving this technique of extended body, we must think about an elements. So in case of an hollow hemisphere, we must think about the element is a ring. So I will consider one elementary ring. This is my elementary ring. And I said this elementary ring I connected like this and I connected like this. And what is the radius of this elementary ring? I said the radius is small r, and the thickness, this thickness part, whatever the thickness section is here, I said this thickness part is dr. And I consider this is angle is theta and this angle is d theta. This is theta and this is d theta. I hope the scenario is everything is pretty clear to all. So what I consider a hollow hemisphere, non-conducting hollow hemisphere having surface charge density is sigma and radius of this hollow hemisphere is r. I know that hollow hemisphere is an extended body, so I will consider an element. In case of a hollow hemisphere, if I will cut the hollow hemisphere, I will consider the element is a ring. So I consider one ring of radius r and thickness is dr. From theta to d theta, I consider an angle. This theta to d theta, I consider this element. Now I will think about the expression of electric field at the center. O. What I will write, I will think about the expression of electric field due to this elementary ring. If I will go back to my previous lectures, I already said if this is a ring of radius r exactly on the axis x at some distance, if p is a point, we can directly write the expression of electric field, and this expression of electric field we can write as k q x upon r square plus x square whole to the power 3 by 2. Exactly, you can easily write this expression. Electric field on the axis of a ring having distance x and radius of the ring is r. If you look carefully, this ring, this is a ring and the radius of the ring is r. So what can I write the expression of, and this is my axis? Yes, this is exactly from center to this axis. Let me redraw the scenario. This is my ring whose radius is small r, and this axis, this is point O. I know this is r, this is capital R, the radius of the hollow hemisphere. If this angle is theta, can I say this is r cos theta? And this radius, what I consider small r, this is r sin theta. Yes, I can say if this is r cos theta, this is what? R sin theta. So if I'll write this expression as, this is an elementary section, so I'll write my expression of electric field. This is dE. dE can be written as k due to this elementary charged ring, the charge is dq, and what is x? This is r cos theta upon r square plus x square. This is my r, this is r sin theta whole square plus this is x. In case if this is x, this is now x, this is r cos theta whole square. So let me do simple mathematics. K dq, this is r, and this is what expression is whole to the power 3 by 2. This is r cos theta and this is r square sin square theta plus r square cos square theta whole to the power 3 by 2. I hope the scenario is pretty clear to everyone. So now this is k dq r cos theta upon what? R square, make it common. This is sin square theta plus cos square theta. So I'll say simple sin square plus cos square theta is 1. So this is r square whole to the power 3 by 2. So r square, so this is r cube. And the expression simply coming k dq cos theta upon r cube. R cube r is, this is r square. I hope this scenario is pretty clear to all. So what I write? I write the expression of electric field due to an elementary ring using this expression kqx upon r square plus x square whole to the power 3 by 2. And r, this is r sin theta, this is r cos theta. So whole the expressions during the simple mathematics I reach here. Now what is dq? dq can be written as, this is k, dq can be written as sigma into dA cos theta upon what? R square. Because here surface charge density is sigma, surface charge density what I have considered, this is sigma. So what you can write dq, dq is written as what? Sigma into dA, because sigma equals to charge per unit area. So in this section it is sigma can be written as dq upon dA. So dq in place of dq I can simply substitute that sigma dA. It's not a rocket science at all. So can easily one can substitute. Achha. Let's come to the point here. I want to write the expression here. This is k sigma dA cos theta upon r square. K, this is my expression of electric field. This is dE. This is k. Sigma is sigma. What is the expression of dA? I will write the area of this. dA is the area of this elementary ring. What is the area of a ring? I can say area is nothing but perimeter into thickness. Perimeter is what? 2 pi r, the radius of the ring, into thickness is dr cos theta upon r square. And we know this small r equals to what? R sin theta. Already I said these things. So in place of small r, we can write r sin theta. And little carefully, if someone will observe, this is my dr. This is my dr. And this is, you can say, this is d theta. And this is r. If someone will write the expression of dr, dr can be written as r d theta. Because angle equals to arc upon radius. So using this concept, we can write dr equals to r d theta. So let me write the expressions here. This is k sigma. In place 2 pi is here. In place of r, this is r sin theta. And in place of dr, this is r d theta cos theta upon r square. This is r, this is r. So what will happen? This r square will cancel by this. So expression is coming k sigma 2 pi k sigma, 2 pi k sigma, and this is the expression is coming sin theta cos theta d theta. I can introduce 2, this 2 is inside. So what is the expression is coming? Pi k sigma 2 sin theta cos theta can be written as what? Sin 2 theta. This is the expression of electric field. If I will go for integration, I already put this integration sign here. So what we will do, if we are writing for the expression of small element, we are writing like this. If we are going for the net electric field, one can think about the total integrations. So I must introduce the integrations as I already put here. So this is the integration. Now question is arise, what is the limit of the integrations? If you will carefully observe, what should be the limit of integrations? If I consider my element here, the angle is like this. Little better way if I want to explain here. This is the hollow hemisphere, talking about the limit section. If I will consider my element here, the limit will be like this. Theta is like this. If I little more larger ring, the theta will be like this. Little more larger ring, a student must have to imagine these things, the theta will be like this. So one can think the theta minimum, if I will consider a small element here, the theta is very small, it is 0. And it is goes on increasing, and maximum it will cover an angle of pi by 2. The student must be aware about these things. So this, if the minimum is 0 and maximum is pi by 2. And everybody know what is the expression of this is pi k sigma. What is the expression of integration sine 2 theta? Sine 2 theta integration is minus cos 2 theta upon what? 2. This is very fundamental level of integrations. Sine 2 theta integration is sine theta integration is minus cos theta. So sine 2 theta integration is minus cos 2 theta upon 2. This is the normal integration. Student must aware about this. This is 0 to pi by 2. If I will interchange the limit, what is the expression is coming? Pi k sigma upon 2, and I will put interchange this limit. This is cos 2 theta. This is now 0. This is now pi by 2. If I will remove this negative sign, I must interchange the limit. Let me available space here. I will do this integration to here. Let me in this available space I must doing this integration. This is pi k sigma cos 2 theta. In place of theta I will put 0. So this is now cos 0 minus cos 2 theta. In place of theta I will substitute pi by 2. I will get cos pi. So cos pi. So pi k sigma, this cos 0 is 1 and cos pi is minus 1. So what is the expression I am getting? 1 2 is already here. So I must introduce 1 2 is here that I missed. This is my 2. So expression is coming pi k sigma. This is 2 upon 2. This 2 cancel. The expression is coming pi k sigma. And I will substitute this value of k, and we know the value of k is 1 by 4 pi epsilon naught. This pi and phi has cancelled, and we are getting the expression as sigma upon 4 pi epsilon naught. This is the expression of electric field at the center of a non-conducting uniformly charged distributed hollow hemisphere having surface charge density is sigma. For one more time, for the student perspective, I want to discuss it again for the better view of the student. What I have considered a hollow hemisphere. Let O is a center of the hollow hemisphere of radius r having surface charge density is sigma. This hollow hemisphere an extended body, so I have to consider an element. In case of a hollow hemisphere, a student must imagine these things, that hollow hemisphere is made of rings, large number of irregular rings you can say, having different radius rings. If you cut hollow hemispheres, you will get one ring. So I consider one elementary ring of radius smaller having thickness is dr. From theta to d theta, I make subtended some angle. This element theta to d theta, I consider one angle. And I know the expression of electric field exactly on the axis of the ring is kqx upon r square plus x square whole to the power 3 by t. So this elementary ring O is a point exactly on the axis of the ring, and the axis is here r cos theta, and this small r, using the vector technique, if this is r, exactly this is r cos theta and this is r sin theta, and substituting this r sin theta, r cos theta using the elementary ring axis electric field expression, I am writing a small elementary electric field, and proceeding in the similar fashions I reach to this point, and I know dq can be written as surface charge density into area of the element, surface charge density into area of an elementary rings area. And what is the elementary rings area? That is you can say perimeter of the ring into thickness. So in place of small r, I substitute r sin theta, and in place of dr, I introduce this angle equals to arc upon radius concept, and this dr equals to rt theta, and simply I will integrate all the elementary rings. If I will do the integrations, I will get the expression of electric field of the hollow hemisphere. And proceeding in the similar fashion, sin 2 theta integrations, that is sin 2 theta integration is minus cos 2 theta upon 2, and very important part is what is the limit of the integrations. Minimum angle it can subtended here 0, and maximum it can goes to 0 to pi by 2. This is very important. A student must have to be think about it. So 0 to pi by 2. Proceeding very simple mathematics, putting the upper limit and lower limit, will reach to the conclusion that expression of electric field due to hollow hemisphere at the center is sigma upon 4 pi epsilon naught. And we all know that electric field is a vector quantity. What is the direction of the electric field? Due to, we know the expression of electric field due to an element, due to a ring, the electric field expression will be like this. So this is an elementary ring. So due to this elementary ring, the expression of the direction of the electric field will be like this. There will be so many elementary rings I will draw, the exact direction will be like this. So I can say if this is x axis, this is y axis, the direction I will say this is minus j cap. This is your magnitude form and this is your direction form. I hope this question is clear to the student, and competitive point of view, these questions can help you little. And one more thing I can say, if you look at this electric field, this sigma is a uniform surface charge density. This 4 is also a constant, epsilon naught electrical permittivity of free space. So this electric field giving rise to a constant value. That will be must in your mind, that it is sigma upon 4 pi epsilon naught. Thank you everyone. Thank you for your watching. Thank you.